All right, so today what we're going to do is we're going to continue our look at the Cartesian plane, and we're going to talk about plotting linear relationships. Okay? So remember that we've been looking at relationships with numbers. We've had the nth number, then you found out what value that is by using those linear rules. Well, we're doing the same thing here, and you're going to see how that relates to the Cartesian plane. So I'm just going to go to the Education Perfect lesson to this, and we'll walk through there. Again, I'll underline and write the things that I want you to write down, so make sure that you pay close attention to what we need to write down. There'll be some of it that's kind of a review. You can write it down if you want to, but I'll tell you exactly what I expect you to write down this time, okay? All right, so let's look at it. All right. Pretty appropriate for the time of year, yeah? Guy Fawkes? Yeah. That's Guy Fawkes. So, because we're going to do some plotting. He was plotting. Yeah, get it? Too funny. Okay, guys, come on. Plotting simply means... the word plotting simply means drawing points on a graph. So there's your first notes, right? So plotting, anytime you're told to plot something, plotting means just draw points on a graph, okay? So you're just drawing those points on a graph. And what happens when you're doing that is you're drawing a picture of the information that you have. Because if you look at just a chart of numbers, it's sometimes difficult to answer questions about just seeing a chart with some random numbers on it, right? But if we plot it or draw a picture of it, then there are some questions we can answer easily by looking at the picture, right? And we're going to be looking at that quite a lot, okay? So plotting simply means drawing the points on a graph. And of course, our graph is the Cartesian plane. Excellent. Okay? All right. And again, the reason why is it just makes things easier to see and easier to read, okay? I don't know why they're showing us a bar graph, because that's not what we're using. So earlier lessons, we looked at putting information in tables, right? So we had a table that looks like this, where n stood for the number, the nth term, so first, second, third, fourth, on into infinity, right? And t is what you get when you apply the rule. So for this rule, the first number is what? 1. Well, the first number is a 7. There you go. All right. The second number is 10. Third number is 13. Remember, we looked at those relationships, right? Okay. So, all right. So what we're going to do is we're going to look at how that relates to the Cartesian plane. So when you have a pattern like this, that pattern is called a relationship, right? In other words, those numbers are tied together and cannot be separated. For example, in this pattern, the first number has to be what number? 7. Can't be anything else. The fourth number must be 16. Can't be anything else, okay? So they're tied together. They form a relationship. They work together, okay? Now again, they're using n and t here. We talked about this. Your axes don't have to be x and y. You can label them any numbers that make sense for what you're doing. So if we were looking at time and cost, for example, we would use t for time, c for cost, yeah? Remember when that last part of the lesson was labeling those axes? Making sure that if we did have time, we had to put in our units. If we did have cost, we had to put in our units. So if it does have units, then you need to put those in. So think about that when you're plotting these, okay? And in this case, though, there's simply numbers. So would there be any units? No. So, but you would label the x-axis n, the y-axis what? T. So the first one is always going to be your x-axis. The second one's always going to be your y-axis. All right? Okay. So anytime you have a pattern, that forms a relationship. I want you to note the pattern and relationships. Yes. Okay? All right. Okay. So, to give you an example, think about gears. If gears are linked, if one of them turns, it's going to turn the other one, right? And if you turn the first one faster, what's going to happen to the second one? It's going to move faster, right? So what happens with the first one affects the second one. Yeah? And that's exactly what relationships, number relationships do as well. If you change the first one, it's going to change the second one in a reliable relationship or pattern. It's very predictable. Okay? So, many people think of this as like a machine. If you put in a certain number, it's going to give you another number out. Okay? And that's what linear rules do. So if you change n, you also change the t. Okay? And we're going to spend a lot of time talking about these types of relationships. So let's look at how to plot a relationship on the Cartesian plane. Again, remember that the Cartesian plane, because you have two axes, now, and there's no spot on here that doesn't have an x and a what? A y value. The Cartesian plane was designed specifically to plot this kind of relationship, where you have two numbers that have a relationship. Okay? So we can plot those relationships on the Cartesian plane simply by plotting each point. So remember that you can change the labels for the axes to fit your situation. In this case, we have an n and we have a t. So what they've done is they've replaced the x with our n and our y with our t. The values don't matter. The order does. So when we had our chart, remember n was the first one and then t was the second one. So that means that n has to be the horizontal, the x-axis, t has to be the y, because of the order in which they appear in the relationship, right? And make sure you're always careful about the particular order of them. But again, just like we did last time, you can change the labels of the axes to fit your situation. So again, we have our pattern. The first number is always 7, the second one's 10, the third one's 13, etc. The pattern will not change. And so all we're going to do is plot these points on our Cartesian plane. So you'll see that if the first relationship was 1, 7, we could even write that as an ordered pair, 1, 7, and ordered pairs are always enclosed in a what? Bracket. In a bracket. So, and to plot that, starting at the origin, we're going to go to the right 1, and then up 7, and that's where our dot is. Okay? The next one, oh, that's weird. All right, the next one is 2, 10. Oh, Lord. All right, so that means go to the what? To the right 2, and then what? Up 10. So that means we'd get another point there. Okay, let me erase those lines because I don't want them on there. Come on. Being weird on me now. So 210 would be right there.
Yeah, that's 1, 7. There you go.
There you are. Okay? All right. The next one was 3, 13. So that means to the what?
3.
To the right 3, and then what? Up 13. So that would be right there. Okay? And then we had 4, 16. So that's to the what? Right 4, and then what? Up 16. So that would be right there. And what do you notice about these dots?
It's going up in green.
Well, look at the alignment of it, though. What do you see? They're lining up in a straight line, aren't they? Okay. Isn't that a straight line that we have going on here? So that's why they're called linear relationships. Because if you plot them, they line up in a straight line. Okay? Now, we'll talk about in a minute, because most of the time you're going to want to try to draw a straight line, but we'll talk about when that's allowed and when it's not. If you're just plotting points on it from a relationship, you don't normally connect them with a line. You just plot the points. Okay? Now, some of you were wanting to answer other questions about these, and you can. What do you notice about the dots? As you go further on, they are what?
Increasing by 3.
Increasing, and by a specific number. They're increasing by 3. Okay? They make a diagonal, and that diagonal line is going upward. Yeah? And that's the kind of thing that we're going to be looking at as we analyze these. Okay? Now, so again, each one of those sets of numbers creates an ordered pair, and here that you see that they're all plotted for you. Okay? Again, remember, it's not over or across, which they even use in their directions. I hate that. It's right or what? Left, and up or what? Down. If you say across, it will always hinder you. Right? Now, right now they're saying across because the only way you can go is to the right, because that's all they have on their graph. But that's not the way it's going to stay. So be careful. Right? So you're going to, in your homework, you're going to be asked to plot some points on the table. So let's just go through this one together. Very easy relationship here. So the first pair of numbers was 1, 1. Right? So that's what? Right 1 and up 1. Good. Then the next one was 2, 2. What's that mean? Right 2 and up 2. Then 3, 3. Right 3, up 3, and blah, blah, blah. I don't even have to plot the rest of them because I know what's happening, don't I? So I even went way beyond the numbers that were on the chart. It's just every time you increase by 1, you increase the bottom number by 1. What do you notice? They all line up in a straight line. So if I got one over here, I know that I've plotted it wrong, right? So make sure that you use what you know about them to be able to check your work. That's good? All right. So you're going to have some of those in your homework, or in your, well, probably you can do it in here, where you're plotting those. Okay? Anytime you have a table which represents a pattern or relationship, you can plot it on the Cartesian plane. So here, same one we plotted a while ago. Yeah? Okay. They always lie in a straight line. That's what a linear relationship does, is make sure they always line up in a straight line. Okay? All right. So, this is critical. All right? Can you connect the dots when you have a straight line? Can we connect the dots to make a straight line? Well, the answer is sometimes.
Should we just write you cannot always connect the dots to make a straight line?
Okay. Well, sometimes. Sometimes you can connect the dots. Sometimes you can't. Because every time you plot those, notice that it was representing a whole number. Now, there's a reason that there's a cat there. So let's say we were plotting a thing with a cat on it. Okay. If you're between 1 and 2, there are lots of numbers between 1 and 2, right? But they're fractions or decimals. When's the last time you saw half a cat walking around? Right? Not good. Yeah?
It was run over by a cat.
Well, okay. So it probably wasn't walking around if you only have half a cat. Yes? So if it's between like 1 and 2, it's not a whole number, right? Can you have part of a cat? No. Not. Oh, come on. Okay. That's why, hold on guys, come on. That's why it says sometimes. It depends on the context. Yes.
Doesn't that mean that if it's like saying age or height and...
Right. So let's just go through a few scenarios. I want you to tell me, would it be appropriate to use dots or a line? If you can have parts of it, then a line is the appropriate thing to do. But if it can't be parts, then it has to be whole. It just has to be dots. So, how about if I was drawing a graph that was all of you guys in class? Dots or line? Dots. You cannot cut pieces of you in, right? This is not going to happen. You can't have part of a student, right? But what if I was graphing your ages? Are you only 1 year old, 2 years old, 3 years old? No, you can be in between. Yes? Mm-hmm.
Can you do 0.5, 1.5 on the graph?
Again, it depends on the context. Yes, you absolutely can. Okay, so what if I was doing, I don't know. Let's just look at some examples.
Can half pieces
Right, exactly. So if I was doing pizza, does it always have to be whole? No.
Yes.
You can have lots of different pieces of a pizza. Okay? So if you draw a dot with the connections, it means every point on the line is part of that graph. If you plot a relationship with kittens in a video and the number of views it gets, you can't connect the dots. Can you have half a cat? No. So you can't connect the dots. And if you view a video, you've either viewed it or you what? Haven't. So, yes, you could watch it for a bit and turn it off, but they're asking, did you view the video? Yes or what? No. So that one is not appropriate to make a line. Okay? Now, because you can't have a video with 2.5 kittens and get 7.5 views. Right? Doesn't make any sense. Can't have half a kitten or half a view. You either viewed it or not. Okay? Oh. But you've still viewed it. The question is, did you view it or not? There you go. Doesn't matter how much of it. Now, look at this one though. In this one, it's the time spent studying versus the time spent watching cat videos. Do you have to study for exactly an hour? No. Could you watch videos for exactly an hour or more or less? Yeah. So in this case, guys, in this case, it's appropriate to connect those dots because you can watch for half an hour or spend an hour studying, etc. Okay? All right.
Okay, not all of them are boring, but most of them are.
Wacky cat. All right? So, studying for parts of an hour makes sense in that situation, so you can connect the dots. So, if you connect the dots, and in a situation where it's inappropriate to connect the dots, even if all of the dots are perfectly correct, the answer is wrong. Right? Because you're not allowed to cut those cats in half. It's not going to allow it. Okay? Yes?
But if it's like, if you can connect the dots,
Then you must. Yes.
That's still
What the heck? How does this happen?
It's still wrong.
Wait.
Okay?
So if the dots are like in parts, then you can do.
Yes. If you can have parts, then you should always draw a line. Right?
If you watch the video for half.
Yeah, watching a video, the time you spent. Time can be
But
parts.
if it's like something wholesome, like you have this many cats, then you have to do dots.
Exactly, because you're not allowed to cut them in half. Yes. Okay?
dead cats.
No.
Exactly.
Don't be killing these cats. All right? Now, come on, guys. One of the main reasons we're going to be using these graphs. All right, so what we're going to do, one of the reasons why we plot things is so that we can read information easily from a graph. Okay? Because most people are more comfortable with a picture of the information than just a chart full of numbers. Okay? There's a lot of information we can get. So we're going to talk about what kind of information we can get from reading graphs. And the first thing is that if you have a relationship and it's displayed as dots, we could turn those dots into a table, right? By simply reading the ordered pairs. Okay, so this one is the number of stoats and the number of, how do you say that word? Pukeko. There you go, thank you. All right? And you can display this information in a table. Now notice, they did dots, not a line. Why are dots more appropriate here and not a line?
Because you can't split a pukeko in half.
Right, if you split it in half,
They're not murders.
yeah, they're definitely not dead ones. Yes.
Kill the pukekos.
If you don't have any sort of subjects on each side.
Yes, there'll always be labels. Yeah.
Okay.
Now, if you just had X's and Y, you could still make a chart. If that was X and that's Y, you could still make a chart. You just have to call it X and Y.
But you would be able to put a line through it.
No, in that case, it's just numbers. You could definitely put a line through it. Because if it's just numbers, can numbers be fractions or decimals?
Yes.
Yeah, then you don't care. It's usually this kind of thing that restricts you when you have a specific type of thing going on. Numbers are never restricted, so it's a good one. If you have just N's and T's And you could put a line through it if your pattern allows. But if it's just X's and Y's, you definitely can. So all we're going to do is read these points and make our chart. So here we go. So if you look first at the very beginning, if you look at the graph, the first point is right there on the y-axis. Okay? So if it's on the y-axis, how far right or left did I go? If I stayed on that axis, I didn't go anywhere, right? And so that means that the first number is 0. So this point is 0. Now, did I go up or down? Yep. Up and down how much? 13. Yes?
How do you know it's the first point?
Well, because it's the first one I see as I'm going right or left. You always read them right or left just like you'd read a book, right? Always from the right to left.
Can I go wash my hands? My pen's been bleeding.
Yes, you may. Okay. All right. Next point, I went to the right 1 and then up 10. So right 1 and up 10 would be what ordered pair? 1, comma, 10. Second one, I went to the right 2 and up what? 7. So that's 2, comma, 7. Next one, I went to the right 3 and up 4. 3, comma, 4. Then the last one I went to the right 4 and up 1. So 4, comma, 1. All right? And we can make a chart of these values. Remember, the x-axis was the number of stoats, and the y-axis was the number of pukeko. So the first value is 0.13. Next we had 1.10. Then we had 2.7. 3.4. Can't read my own writing. And then 4.1. Okay? So just like we could take the numbers from a table and put them on the graph, we can use the graph to build a table. Yes?
I thought it was always the table is always supposed to start on 1.
No, the table can start wherever your graph starts. Yeah. Mm-hmm. Yeah, traditionally, the first number is what we're looking for, but in this case, there's a 0 in there. So it can start at any number. Yes? Good observation.
Like on the bottom line, can't you go like 1, 30?
What now?
Can't you like skip it instead of going 1, 2, 3, 4, 5? 1, 3, 5.
Well, it could be different scale, but in this case, they wanted us to label every point, and so we're looking at the points. It could be definitely a different scale. You could have had a point here, and then a point here, right, skipping, and it would have skipped. You wouldn't have, yeah, there could definitely be, but in this, it's just this particular case. Yes?
On the table, do you need to have the you need to label the...
Absolutely, you have to tell me what it is.
Would you need to have the N and the T? Or would
No,
you write
because in this
down-
case, there's specific items. There's stoats or pukeko.
So would you write stoats and...
Yes.
Okay.
Mm-hmm. Yeah, if it's specific items, then you need to write the names of
So
them.
we don't have
Yes.
to write the
Okay,
number of...
No, you don't need to write number of. Pardon me?
SMT.
You could abbreviate. Yes, definitely.
Do you have to like write stoats and computers, or is it okay if you do like
No, you need. If it's a specific item, then you need to label it because we need to know that what you're talking about, right? Now, if your chart is right next to your graph and your graph has stoats and pukeko, then you can use S and P. But if it's not next to it, if it's something separate for it and from it, and you can't look at it and see obviously that that's what it is, because S could just as easily be stop signs, right? P could be potatoes. So you can't use abbreviations unless you can refer back to something on the same page, right next to each other, right? Okay, good questions, guys. All right.
Does the y-axis always go on the bottom of the...
Yes, it's always the second numbers, right? So it always has to be the bottom one. Okay. Now you could also make that chart going up and down if you'd like, and I often do. You often see these tables going up or down like this. So that could be stoats, and that could be pukeko, and so it's 0, 13. And then you have the first and second one. So either way you want to draw it, okay? But in this case, they gave you one to fill in, so they're using it across.
So whatever x-axis is, it
Right,
always goes
that's
on
always the
bottom.
first one. Right, it has to be the first one, and the y has to be the second one. Every time. Ordered pairs. Remember, they have to be in order. Okay, so they plug those in. Now, What do you notice about these dots? As you move to the right, what's happening? It's descending, isn't it? Okay. And if you think about it, so the number of stoats, as the number of stoats increases, what happens to the number of Keiko? It's decreasing, right? Okay. Right. Because these are eat the babies and eats the eggs, right? Okay. So, yeah. All right. So here's another one where they're doing chart. And this one, notice that it's a straight line. They did the dots this time. Because if you look at it, it's time worked. Can you work half an hour? Yeah. Sure. Okay. And earnings. Do you only earn dollars, single dollars? No, you can earn cents in between, right? So in this case, it was appropriate to write this information in as amounts earned over time. Now, they don't give you any dots, but any dot that you can identify on the graph would be appropriate. And so here's one. Oops, sorry. Okay. So right here, that's a point on the graph. Yeah? What point is that? The origin, which is 0, 0. Now, this point is also on the graph, but could I read it effectively? Do you know what numbers those are? No. So if it's not on one of the intersections of those grid lines, it's difficult to read. Okay? But how about this one? Could I read that one?
Yeah.
Yeah, that's 2 what? 32. So do you see that you can read points from a line? So that's 348. Okay? Right? Missed 1 and 16, but let's shove that in there somewhere. Okay? So you can't read every point, but you can read some of them, right? The ones that you read are going to be the ones that are at the intersections. And that will establish your pattern. Now, the numbers in between don't just go away. They still exist, but it's difficult to read them, right? But you can still establish a pattern by looking at the ones you can identify. Mm-hmm. Pardon me? At some point, you're going to have to read them, but you'll do an estimate. So, for example, if you wanted this point, okay, that's about 1.5. So 1.5, 24, or 1.5, 24, or 3 halves, 24. All 3 different ways of writing the same thing, right? So you just, if it's in between those, yes, you will have to eventually identify them, but the best you can do is an estimate, right? If it looks like a half, or if it looks like a fourth, or 3/4, something like that. Yes, ma'am.
For that, mainly before you were saying that you can go you can see the pattern, you can go up, but do you want us to simplify the pattern, or do you want us to because you can go up and so for instance, if you got 16 and then to 32, we can also go up from 8.5 to
No.
16.
No, it doesn't. It's because they're not fractions. They're 2 distinct numbers. So yes, you wouldn't. You just Well, you just use the numbers that are on the graph. Don't change them.
And my second question is there a particular way you want us to write that, with 1.5?
Yes, we'll look at it in just a second. Yeah. Mm-hmm. Oh, you mean here like these? No. 3 different ways of writing the same thing. This is one that you'll find is the most prevalent. But 1.5 is okay. Decimals are not so great because not everything goes into a nice decimal, right? You can always write a fraction like 1/3. You'd have to round, and rounding's not good. Yes, ma'am.
Couldn't we just, instead of doing that for the answer, can you just make your graph incredibly detailed?
No, because we're asking you values. For example, I want to know how much money does she earn after working 2 hours. So you'll be asked very specific questions about it. So after 2 hours, how much money does she earn?
No, so you can display the data. So you can display the data on.
Yes, but the data is already going to display. They're going to give you the graph. They're going to ask questions about it, and you're going to have to answer the questions. Okay? So in this case, after 2 hours, right? Go over to 2 hours. That gives you $32. So after 2 hours, she earned $32. Okay? All right. So they're already going to give you the graph, so otherwise you wouldn't be doing anything. All right? So amount over time. So here they ask you how much she earned in 3.5 hours. So again, if it's between two numbers, you're just going to have to give an estimate. But after 3.5 hours, how much money did she earn? 56 what? Dollars. Make sure you watch your units. Okay? All right. And again, just find out where those two lines would intersect at a certain point. Okay? Yes. You can bring a ruler if you'd like. Sure. Okay? All right. So what I'm going to do is I'm going to give you an assignment. But before we do that, you need to bring out your laptops, please. We have one other thing that I want you to do.